Today we're going to be learning about function operations. So first let's look about addition with function operations. If we have f plus g of x, it's the same as f of x plus g of x. Subtraction, if we have f minus g of x, it's the same as f of x minus g of x. Multiplication, if we have f times g of x, it's the same as taking f of x and multiplying it by g of x. Same with division. If we have f divided by g of x, it's the same as taking f of x and dividing it by g of x. So let's take a look at a couple example problems for adding and subtracting. So first we want to find f plus g, so that means we're taking f of x plus g of x. F of x is 3x plus 8, and our g of x is 2x minus 12. So then I can combine like terms, so I have 5x, 8 plus a negative 12 is a negative 4. So in looking at it to find our domains, there is no values of x, that we end up with no solution, so this is a domain of all real numbers. So let's take a look at subtraction. So it would be f of x minus g of x. F of x, 3x plus 8. We're subtracting the quantity of 2x minus 12. So when we distribute our negative 1, we end up with 3x plus 8. Negative 1 times 2x is a negative 2x. Negative 1 times a negative 12 is a positive 12. So combining like terms, we end up with 1x plus 20. And our domain is all real numbers. So for our second one, adding f plus g, so f of x plus g of x. F of x is 3x squared minus 4x. We're adding 2x minus 5. So if we combine our like terms, 3x squared, negative 4x plus 2x is a negative 2x minus 5, and our domain is at all real numbers. So f of x minus g of x. F of x is 3x squared minus 4x. And we're subtracting the quantity of g of x, which is 2x minus 5. So that means when we distribute our negative 1, we end up with negative 2x plus 5. So if we combine our like terms, negative 4x minus 2x is a negative 6x plus 5. Our domain is all real numbers. So now what happens when we work with multiplying and dividing our functions? So first let's start with multiplying. So that means we're taking f of x and multiplying it by g of x. So f of x is x squared minus 1, and we're multiplying that with x plus 1. So if we FOIL, x squared times x is x cubed. X squared times 1 is x squared. Negative 1 times x is a negative 1x. And negative 1 times 1 is a negative 1. Here we have no like terms, so there's nothing more we can simplify down to. So that's our final answer. And our domains. In this problem too, there is no limitations on what our x value can be, so it's all real numbers. So now what happens when we divide? So that means we're taking f of x and we're dividing it by g of x. So we have x squared minus 1 divided by x plus 1. And for right now, we are not going to factor and simplify this any further. We're just going to set it up in this, and then we're going to try and look and see if what our domain is. So here, we have to remember when we are dividing, we can never have a 0 in the denominator, because we can't divide by 0. So that means x plus 1 equals 0. So that means x cannot equal a negative 1 in our domain. So it's all real numbers, except for x cannot equal a negative 1. So let's look at one more example of these. So f of x times by g of x. F of x is 6x squared plus 7x minus 5 times by the quantity of 2x minus 1. So 6x squared times by 2x is 12x cubed. 6x squared times a negative 1 is a negative 6x squared. 7x times 2x is 14x squared. 7x times a negative 1 is a negative 7x. Negative 5 times 2x is a negative 10x. And negative 5 times negative 1 is a positive 5. So if we combine like terms, 12x to the third, negative 6x squared plus 14x squared is 8x squared. Negative 7x minus 10x is a negative 17x plus 5. So our domain for multiplying is all real numbers. So let's take a look at dividing. So we are taking f of x and dividing it by g of x. So f of x is 6x squared plus 7x minus 5 divided by 2x minus 1. So once again, we are not going to simplify any further yet. We're just going to look at this as a whole. So let's look and see what our denominator, or denominator can't equal 0, so let's find what x cannot equal. So if we add 1 to both sides, divided by 2, so x equals 1/2. So if x is 1/2, then our denominator will be 0. So that means our domain is all real numbers except for x cannot equal 1/2.